Good morning students, welcome to the final year. In the mathematics there are the two papers, paper 5 and the paper 6. Paper 5 I will take and paper 6 Sujata madam will handle. In the paper 5 there are the 3 units. In the earlier semesters you were learning in each subject the 4 units, but here it is in the final year it reduces to the 3 units. Here the first unit is algebra 4. That means algebra 1, algebra 2 and algebra 3 you have already learned in the earlier semesters. In the first unit algebra 4 you will learn the chapter that is a rings, integral domain, and fields. Here this is the unit name, rings, integral domains and the fields. In this chapter, first we learn the definition of the rings and problems on the rings and theorems on the rings. Similarly, now we will go another concept, subrings. The next concept is subrings. In the subrings, first you will learn the definition, theorems and problems on the subrings. Later, we will learn the ideals. Again, in the ideals, the definition, theorems and problems. Next, we will learn the homomorphism and isomorphism, the kernel F. As like you learn in the groups, in the similar manner, this is the rings is the what? The extent part of the groups. That means homomorphism, isomorphism and the kernel F. Kernel of the what? The rings you are learning in this chapter. And the one more concept, that is a what? The quotient rings. This is the what? The unit 1. Clear? The next unit 2 is the calculus 5. That means calculus 1, 2, 3, 4 were learned in the earlier semester. In the calculus 5, the chapter name is the differential calculus. Of a scalar and vector fields, which is the second unit name, the differential calculus of a scalar and vector fields. In this unit, the first we will learn the scalar point function, then the scalar field, okay. Next vector point function, then vector fields. That means we will learn in this chapter the first the definition of scalar point function and scalar field. Similarly, vector point function and the vector field. In this chapter, you will learn the 3 concepts. You know that in the mathematics there are the 4 basic operations: addition, subtraction, and multiplication and division. And how you are applying those operations on the numbers. Here, similarly, on this point function or the scalar and vector point functions, we are applying the 3 operators. Which of those 3 operators is gradient, next the divergence and curve. Which of the 3 operators we are applying on the scalar point and the vector point function? Gradient, divergence and the curve. First, the gradient is always we are applying on the what? Scalar point function. Next, divergence and curves we are applying on only the vector point function. This is the unit 2. Next, unit 3, numerical methods 1. Clear? This is the new concept you are learning in the paper 5. the continuation part, the numerical methods 2, we will learn in the what? The 6th set. Under the numerical methods 1, we will learn the what? The finite differences. The finite differences. In that, there are the 4 operators. One is the what? The forward difference operator. We are denoting by the what? Delta. And the backward difference operator, del or nebula. And the central differential operator, the small delta. And the shift operator, E. And the differential operator, capital D. In the finite differences, we are learning the 3 operators: the forward difference operator delta, backward difference operator del, and the shift operator E, and the central difference operator is small delta, and the differential operator is capital D. In this, we will learn the definition of these operators and the relation between them. Next, we will learn the what? The nth differences of a polynomial. Nth differences of a polynomial. Next, the factorial notation. Then, the separation of symbols. Then, in the nth differences of a polynomial, factorial notation, and separation of symbols. Next, you will learn the divided differences. Totally, you will learn 3 types of the differences. First one is the finite differences. Next will be what? Nth differences. And next will be the what? The divided differences. All these are the what? The basic concept. The next there are the what? Very important concepts. That is the what? The Newton formulas. That is, which are the Newton formulas? There are the 2 Newton formulas. Newton Gravre forward interpolation formula. And similarly, the next one, Newton-Gravre, the backward interpolation formula. These 2 interpolation formulas we are applying on only the what? The equal intervals. The equal intervals means the nodes. The nodes means the x values. If the x values have the what? The equal differences, then we can apply the what? These 2 formulas. If it is there given as the nodes are unequal intervals, now we are applying the only one interpolation formula, that is the Lagrange's interpolation formula. Interpolation formula. This one we are applying for unequal intervals. This is these 2 formulas we are applying for only equal intervals. Here, next we will learn the what? The concept, the inverse interpolation. Inverse interpolation. The next concept in this unit, the numerical integration. In the numerical integration, you will learn the quadrature formulas. Formula means singular, formula means the plural word of formula. Here, in the quadrature formula, there are the 3 types of formulas we are using. That is the what? The trapezoidal rule. Then, Simpson's 1/3 rule. Next, the Simpson's 3/8 rule. This is the what? Brief explanation about the what? The syllabus of paper 5. Now I will start the syllabus. Just first I will take the Unit 2. Unit 2 name is Differential Calculus of a Scalar and Vector Fields. See here in this chapter I have already told you are discussing about the what? We are learning scalar and vector point function. See, the word itself shows what is meant by the scalar function is the physical quantity which has only magnitude is called the scalar. Similarly, the physical quantity which has both magnitude and direction, then we call it as a what? Vector. This is the what? Basic concept. What is meant by scalar? The physical quantity which has only magnitude, then we call it as a scalar, and the physical quantity which has a magnitude and the direction, then we call it as a what? The vector function. Now, we need the what? The definition of the scalar point function and the vector point function. Scalar point function. Okay, you know that the three-dimensional space, that means the three-dimensional space means the coordinate axis x, y and z. Clear? This is a three-dimensional space. How we are denoting the three-dimensional space? In the coordinate axis x, y and the z. Just now you consider the what? The some region capital R. In the region R, just we are considering the what? Some point P. Here, first you will see here the point P which is lies in the region R or which is in this three-dimensional space that is x, y, z coordinate. That means the point P, which are the coordinates will be there? X, y and z. If we take the two-dimensional space, only the what? The two coordinates, one is the x and another one is the y. Clear? Then the point P which has only the two coordinate points x, y. Usually we are taking the what? The three-dimensional space. That means first you want to consider the region R which is in the what? The space or three-dimensional space. Then for each point P of x, z, y, z which associate the what? The some real value function pi, then pi of x, y, z is called as a what? Scalar point function. Once again I will write. Consider a region or which is in a space that means the three-dimensional. Clear? Then in this or in that for each point P of x, y, z, points were always represented by capital letters P of x, y, z associates with a real unique value, that is pi of x, y, z. Then pi of x, y, z is called a scalar point function. Once again I will explain the scalar point function. What is meant by scalar point function? Consider a region R. This is the region R which is in space. Space means x, y, z axis, that is the three-dimensional space. In this region R, for each point P of x, y, z which associates the what? Some unique. See, this is a very important. Unique means the particular. That is unique real value function pi of x, y, z. Then we call it as a what? Pi of x, y, z is a scalar point function. Clear? Next. Similarly, now I want to know the what? The scalar P. The scalar P. Clear? This is the point P. Once you see here, the same. This is a what? The region or this is the some point P of x, y, z. If the set of the points which is lies in the region R associates with or together with the functional value pi of p, then we call it as a what? All this region, this field we call it as a what? The scalar field. Once again see what is meant by the scalar field. The points of the region R. Where it is these points? These points are lying in the what? Region R, which is together with the what? The function pi of p, that is the scalar function. Then we call it as a what? This field is called as a what? The scalar field. Okay. Next, the vector point function of vector field. First, we are going to learn about discuss about the vector point function. In the same manner, consider a region or capital R, which is in a space. In that, for each point t of x comma y comma z associates with a unique vector function, vector f of x comma y comma z. Here in the same manner, say here, consider a region capital R which is in a space. In this region, the each point p of x comma y comma z associates with a what? Just little difference between the scalar point and vector point function is unique vector function. Clear? Just see here the same concept. This is a three-dimensional space and the region R and the point P of x comma y comma z, which this point associates with the what? Some unique vector function, vector f, then we call it as a vector f of x comma y comma z is called a what? The vector point function. That means scalar point function means it has no direction at all. That means the pi, just we are considering only pi. In the vector, just see here, we denoting the what? Arrow mark above the letter f. That what indicates a what? Vector. Here, vector means indicates the unit vectors, that is I is a unit vector along the x-axis and j is the what? Unit vector along the y-axis and k is the what? Unit vector along the z-axis. Clear? This is the difference between the scalar point function and the vector point function. See, everything is same in the scalar point function. Just we are saying as p of x comma y comma z, which associates with the what? Unique real value. Real value is scalar function. In the vector point function, just the point p of x comma y comma z associates with unique vector function, that is vector f of x comma y comma z. Similarly, the vector field. What is meant by the vector field? Means the points. This is a point P. The points in a region are here. The set of all the points which is in the region are together with the function vector f, then it forms the what? Vector field. All this field we call it as a what? The vector field. That means all the points which possess the what? The vector function vector f, then we call it as this field is called a vector field. Just I will give an example for the scalar function how we are denoting. That is the function, the scalar function pi of x comma y comma z. Just we are denoting as a like this is the x2 plus y2 plus z2. Just now see here, is there any ijk coordinates? No coordinates. Then it is called as a what? The scalar point function. That means it has no direction. Similarly, just I will define the vector f of x comma y comma z is equals to what? X into I cap plus y into j cap plus z into k cap. Just now see here the coordinates. Which are the coordinates? That is unit vectors. I, j, k is there. Then we can call it as a what? That is a vector. This is the major difference between or minor difference between the what? The scalar point function and the vector point function. scalar point function and vector point function, scalar field and the vector fields. I already told there are the three operators we are learning in this chapter. That is the gradient, divergence and the curl. The first one is about the gradient of a scalar field. Here, first you want to remember the gradient, this operator we are applying only on the scalar field or the scalar point function. We are not applying on the vector function. Clear? That is, before going to the definition of the gradient, we need this some vector differential operator. Vector differential operator delta. Sorry, del. Here, delta means just you write in the what? Like this. If you write this is reversible, that is called del. How to read this is del, del, del or nebula. This is it. This is an operator. How to read the del or nebula? How to define the del? That is I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z. This is a what? A basic concept. You want to remember throughout the chapter. What is the formula? Del is equals to I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z. That means I have already told I cap is always the unit vector along x axis. That means x will be there. Then j cap is always unit vector along the y axis. That is dou by dou y. Similarly, the k cap is a unit vector along the z axis. Like this you can remember. Clear? This is about the differential vector differential operator. Then we can write also like that is dou by dou x into what? I cap. That means after the partial derivative we can write I cap like this. That is dou by dou y into j cap plus dou by dou z into k cap. Like this also we can write. Now we are going to define what? The gradient of a scalar field. That means before defining the gradient, just we need the some scalar point function. That is, already the scalar point function we are always denoted by the what? Pi of x comma y. Let pi of x comma y comma z is a function, is a scalar point function defined and is defined and differentiable, is defined and differentiable at each point t of x comma y comma z in a certain region, or which is in a space, then the gradient of pi is defined as del pi. Here, that is the del pi formula. We can write like this is del. What is the operator del formula? That is I cap into what? Dou by dou x plus j cap into what? Dou by dou y plus k cap into what? Dou by dou z. This operator we want to apply on the function pi. Here, that is equals to what? I cap into dou by dou x on the pi. And how to denote that is dou pi by dou x plus j cap into dou by dou y of pi is dou pi by dou y plus k cap into dou by dou z of pi is dou pi by dou z. This is the formula for gradient of pi or the grad pi or the del pi. Here, this can also be denoted as grad pi. Once again, we have it there. How to define the gradient of a scalar point function? First, we need to define the function. Let pi of x comma y comma z is a scalar point function is defined and it is differentiable. Differentiable means what? We want to be differential. That means we can find out the what the partial derivatives. That is dou y by dou x and dou y by dou y and dou y by dou z. Clear? Then at each point p of x comma y comma z in the what some certain region or just I already told it is in the space means not in the full, just in the some certain region or the pi is a what differentiable and defined. Then the gradient of a pi is defined as del pi. We can read like this or grad pi. Del means what is it? Nothing but grad pi. How to denote or how to define? Del pi is equals to, what is the formula for the del? I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z. This is the formula for the del. Put the bracket and later write the function pi. Now apply the what? Each partial derivative on the what? Function pi. That is I cap into what? Dou pi by dou x. Similarly plus j cap into what? Dou pi by dou y plus k cap into dou pi by dou z. That means you want to remember the two formulas. Del is equals to I cap by dou x plus j cap into dou by dou y plus k cap into dou by dou z. Just only the small difference between these two. What is that? Is means here no function is there. Just you are adding the function. Clear? That is the del pi or the grad pi is equals to what? I cap into what? Dou pi by dou x plus j cap into what? Dou pi by dou y plus k cap into what? Dou pi by dou z. Instead of pi, we can write some other symbols that del side. How can you define the del side? I cap into what? Dou by dou x of z. It is dou xi by dou x plus j cap into what? Dou xi by dou y plus k cap into dou xi by dou z. That means we can replace instead of pi any other function. These are the two formulas. See here, pi is a scalar point function, but the gradient of a scalar point function is always a vector. Why it is a vector? I already told. If I, j, k coordinates is there, then we can call it as a what? This is a vector point function. First, you want to remember what is the gradient of a what? Scalar point function. Gradient of a scalar point function is a vector point function. What is that meaning? The first point you want to remember, the gradient of scalar point function is always the what? Vector function. That means after applying the gradient on the scalar, we will get the what? The vector function. Next, you want to remember that is the then modulus of the del pi. How to find out the modulus is equal to what? The square root of, clear? Square root of dou pi by dou x whole square plus dou pi by dou y whole square plus dou pi by dou z whole square. Here, what is the formula for the modulus of the grad pi? Modulus of grad pi is equals to square root of the I coefficient square, which is I coefficient dou pi by dou x whole square plus j coefficient square, that is dou pi by dou y whole square plus k coefficient square, that is the dou pi by dou z whole square. This is the formula for the modulus of the grad pi. See how can you remember this one? See here, you know that vector or is a what? The position vector of the what? X into I cap plus y into j cap plus z into k cap. Or is a position vector which is in the 3-dimensional. How can you write? X into I cap plus y into j cap plus z into k cap. How to find out the modulus of the any vector? Modulus of vector or is equals to what? The square root of the square of the what? Coefficient of I cap. Which is the coefficient of I cap? X. Its square, that is x square plus j coefficient, which is the j coefficient y, its square, that is y square plus k coefficient is z, its square is z square. In the same manner we are applying the what? The modulus of grad pi. In the I coefficient is dou pi by dou x, and j coefficient is dou pi by dou y, and k coefficient is dou pi by dou z. These formulas you want to remember. R is equals to what? Modulus of vector R. Clear? Similarly, the R cap is a what? Unit vector along the vector R. How to define that is vector R divided by what? Modulus of vector R. All these formulas you want to remember. The one more formula, that is the what? The dot products you already learned in the what? In the earlier semesters, that is I dot I is equals to 1. That means the dot product of the what? The same unit vectors is always a 1. Next, that is also is equals to what? J dot j is equals to 1. Similarly, k dot k is equals to 1. And the dot product of the similar unit vectors is 1. The dot product of the what? The two different unit vectors is always the 0. That is I dot j is equals to 0. Next, what is the j dot k? That is 0. That is equals to k dot I. This is also 0. Then you want to remember this concept, that is I dot I is 1, j dot j is 1, k dot k is 1. Similarly, I dot j is 0, j dot k is equals to 0, and k dot I is equals to the next. After knowing the definition of the del pi or grad pi, now we are going to learn about the what? Properties of the grad pi. The first property, show that d pi is equals to what? Grad pi or del pi dot d or vector. This one you want to show it, where the directional derivative d or vector is equals to what? Dx into I cap plus dy into j cap plus dz into k cap. See here, in almost all the problems we are considering the LHS and we are proving as a what? RHS. But it is difficult to prove as LHS to RHS in this case. In that situation, we are taking the what? RHS and proving as a LHS. Now consider the RHS, that is grad pi dot d or vector. You know the formula for the grad pi. What is the formula for the grad pi? That is I cap into dou y by dou x, or first we can write as the dou pi by dou x into I cap plus dou pi by dou y into j cap plus dou pi by dou z into k cap. The dot product of d or vector, what is d or? Dx into what? I cap plus dy into j cap plus dz into k cap. You know that how to find out the dot products? First coordinate. What is it here? Dou pi by dou x. Multiply this one to this one first. Dou pi by dou x into dx. Next, I dot I is 1. Here 1 into this term is dou pi by dou x into dx plus, then multiply this one with the what? The next term, dou pi by dou x into dy into I dot j. What is I dot j value is 0. 0 into the term is 0. Clear? Plus, then dou pi, this term with the first term of the second one, dou pi by dou x into dz, and I dot k is again 0. Clear? Plus, this term is over. Next we go for the second term. Multiply again with each term in that one. Dou pi by dou y into dx. Then j dot I is again is a 0. Plus the next term, dou pi by dou y into dy into j dot j is 1. 1 into the term is dou pi by dou y into dy plus dou pi by dou y into the what? Dz into j dot k is 0. Here the second term is over. Next you multiply into the what? The third term. That is dou pi by dou z into dx. K dot I is 0 plus dou pi by dou z into dy. K dot j is 0 plus dou pi by dou z into dz into k dot k is 1. that is dou pi by dou z into dz. Clear? Then write down the quantity terms dou pi by dou x into dx plus dou pi by dou y into dy plus dou pi by dou z into dz. See, while finding the dot products, please keep this point in your mind. That means only the what? I coefficients only you will get the value. Clear? Which are the high coefficients? Dou pi by dou x into dx. Multiply these two one. That is I dot high is 1. If you multiply this term with any other term, the value will be 0 because I dot j 0 and I dot k is 0. Similarly, what multiply only what? J with j only. The remaining terms is 0. That is dou pi by dou y into dy. J dot j is 1. Similarly, k multiply with the k coefficient. The k coefficient is k dot k is 1 and dou pi by dou z into dz is 1. You know that already learned in the first semester the total derivative concepts. How can you write that is dou pi by dou x into dx plus dou pi by dou y into dy plus dou pi by dou z into dz can be written as the what? dy. This is the what? The total derivative of the what? If a function pi is a composite function of the what? X, y, z. This is what? LHS. Therefore, you have proved that grad pi dot pure vector is always equal to the what?